Hey guys, this week we are going to be looking at cones. We are going to be doing two things with cones. We're going to be doing surface area and we are going to be doing volume. Up until now we've been finding the volume of all the different types of shapes and things like that. So today we're going to do surface area first and then volume of a cone also. So if you look, a cone, we know what a cone looks like. It has a circular bottom, slants up to the top, and has a point on the top. We are doing surface area. Remember that area is units squared, okay? And basically surface area basically means if we wanted to wrap it like a present. If we were going to wrap a present and wanted to know how many square feet of wrapping paper to use or something like that, or if we wanted to paint the outside of it, then that would be what we would be finding is the surface area. We're not finding anything on the inside of it, just the area on the outside of it. Okay, and there is a formula for that, and it's in there, but I'm going to write it again. S is surface area, pi, of course, is pi, r is our radius, so it's pi r squared. That pi r squared is basically just where these numbers are coming from, is the area of the bottom. Okay, that's just a circle on the bottom, so we're going to have the bottom of the cone plus we're going to have pi r L. And L is this slant height, okay? So if we were thinking, let me erase what I put here for just a second. Okay, that, what is labeled as L, it's like a cursive L right here, is the slant height. And when we get into volume here in just a little bit, this going from the top straight down perpendicular to the bottom, that is the regular old height. And we've, just like before, we have just called that H. Slant height, the outside edge of the cone, is a cursive L. Okay, so we just need to plug in our numbers into that formula to find the surface area of a cone. So let's go ahead and look at a couple of examples. Okay, here we have a cone. We know the radius is 4. And we know that the slant height is 6. Okay, so let's just go ahead and write down our formula. Pi r squared plus pi r L. And then we're just going to put in our known values. Pi is just pi. Eventually we're going to use that in the calculator. R is 4, so we're going to have 4 squared plus pi times r, which is 4 times the slant height, which is 6. And just one thing to make sure right here is you want to do the exponent first. So you'd have 16 pi plus 24 pi, because 6 times 4 is 24. And if you put that into your calculator, let's see here, we should get 125.66 inches squared, and it's a squared unit because it's surface area. Okay, so here we have some extra information. We need to make sure that we know what we want to use. It says find the surface area. Okay, so the two things we need to know is the radius is 3. Our slant height, if you notice, it has 4 and 5 labeled. 4 is just our regular old height. We do not use that regular old height for surface area. We use our slant height. So our slant height, that cursive L, is going to be 5. Okay, so then we just have to go ahead and put those numbers into our formula. The surface area is pi r squared, so we're going to have 3 squared, which is 9, plus pi r, which is 3, times L, which is 5. And when we put those together, we should get 75.4 centimeters squared. Okay, moving on, we're going to look at volume. This should be a pretty quick lesson hopefully here. Volume of a cone is just like the volume of a pyramid that we did before a couple weeks ago, which is the area of the base times the height. And since it comes to a point, we divide it by 3. Okay, but we know that the base of a cone is always a circle. So we could write this as pi r squared, because that B, the area of the base, is a circle, and we know that that is pi r squared. And then we would have times the height divided by 3. So you can use either one of these. I'm going to use this one just because I know the base is always a circle. Okay, and notice with this one, this over here, that would be the slant height. Okay, this is perpendicular right here, so this is going to be our h value. I should make that look more like a h, not like a fancy L. So this is going to be our h. Okay, so all we need to do, let's write our formula. Volume is pi r squared, the area of the base, times the height, divided by 3. So let's plug in our known values. Volume is pi times r squared. Well, r is 2.2 squared times the height, which we saw is 4.5, divided by 3. When you put this into your calculator, make sure you square that before you multiply. Okay, so when you square it, multiply times 4.5 times pi, divide by 3, you should get approximately 22.81 centimeters. In this case, it's volume, so it's going to be in cubic units, so it'd be centimeters cubed. Okay, on this one, you have to look carefully at the information that's given. If we are finding the volume, again, I'm going to write the same formula out, pi r squared times h divided by 3. You have to look at the diagram. Do you know what the height is? We do not know what the height is, means we need to be able to calculate that. And since it's a right triangle, we can use the Pythagorean theorem to find what the height is. Remember, Pythagorean theorem is just a squared plus b squared equals c squared. And in this case, a is going to be 5, so we'd have 5 squared, plus b is h, we don't know what that is, h squared, equals our hypotenuse, which is 8 squared. Okay, so we'd have 25 plus h squared equals 64. And we get that our height is approximately 6.24. Okay, so that's the number that we need to use for our height. We do not want to use 8. 8 is the slant height, not the height. So then we can go ahead and plug in our numbers that we know. Volume is pi r, well, our radius is 5 squared, r squared, that's 25, times the height, we said was 6.24, divided by 3. So we put that into our calculator, and we should get approximately 163.36 meters cubed. Okay, moving on. This one says find the height, which is 8, that's that perpendicular distance, and the slant height, that cursive L, given the surface area. So we know it says surface area, which means we are going to need to use the formula for surface area. So let's go ahead and just write the formula out first. Surface area equals pi r squared plus pi r L. Okay, well, the only thing that we know right now is that the radius, different color, the radius is 3. And we know the surface area is 75.4. Okay, so let's go ahead and plug in the information that we know. 75.4 equals pi r squared, r is 3, so we'd have 9 plus pi times r, which is 3, times L. We don't know what that is. So we'd have 75.4 equals 9 pi, I'm going to write this a little bit different, plus 3 pi L. Remember, pi is just a number, so when you put it into the calculator, I'm going to say 75.4, 9 times pi is approximately 28.27, plus 3 times pi is approximately 9.42 times our slant height. Okay, so as we think about this, we are solving, we're trying to get our slant height all by itself. Well, that's just a two-step equation right now, so we just need to subtract 28.27 from both sides. and we get 47.13 equals 9.42 times the slant height. If we divide both sides by 9.42, it's very, very close to 5. And we're going to call it 5 because it's it's thousandths of 5. So our slant height is 5. So let's go back up here to our picture. And I know that my slant height is 5. Well, now I just have a right triangle where I know two sides. I can use the Pythagorean theorem again. So I'm going to say 3 squared plus my height squared equals 5. Equals 5 squared. Okay, 9 plus h squared equals 25. H squared equals 16, which means our height is going to be 4. And if you, all right, math whiz and you just know some of these things, there are some common Pythagorean triples. A 3, 4, 5 right triangle is a common Pythagorean triple. So some of you might have known just by saying, oh, my hypotenuse is 5 and one of my legs is 3. I know that the other side has to be 4 because it's a triple. So if you didn't, the Pythagorean theorem will tell you what that information is. So the question asks, what is the height and what is the slant height? Again, you had to use the formula to find the slant height, and then you had to use the Pythagorean theorem to find the actual height. Okay, this one, same basic idea, except this time we are using the volume. It gives us the volume. Okay, it gives us the height, and it gives us the volume. So since it says volume, we're going to use our volume formula, which is pi r squared times h divided by 3. Okay, well, it's saying find the radius, so we do not know what that is, but we do know the volume is 678.58. We do know the height is 18, so we can say pi r squared times 18 divided by 3. And you can think about this simplifying in a couple of different ways. You can be like, oh, I can simplify that and call that 6. So you'd have 6 pi r squared. Or you can just go ahead and solve it by getting rid of that 3 in the denominator. So I'm going to multiply both sides by 3. And when I do that, let me see here, I get 2,035.74 equals, okay, so now I don't have that 3 there anymore, 18 r squared, 18 pi r squared, sorry. There we go. 18 pi r squared. If I divide by 18 pi out on both sides, I get that 36 approximately equals r squared. Well, we don't want r squared, we want r, so I need to take the square root. And our radius is going to be 6. And since it's a radius, it's going to be in just units, which is going to be inches. Okay, so make sure I have done all this stuff on the calculator. Make sure you are actually going back and putting the information into the calculator like you're supposed to. Okay, all right, and then last thing here, there's no big ideas assignment this week. Haven't been doing a whole lot of the big ideas assignments. There is a worksheet in Schoology, an answer key in Schoology, and a demonstration of mastery in Schoology. Same thing that you've been doing. And again, make sure you're making an EduCreations video. On that, and good luck.